Hello, explainer of the WAN-AI technology, which is disruptive technology that we're currently deploying on the internet to provide live updates on the optimal level of investment that's required to support popular internet services such as YouTube video streaming and Zoom video conferencing. So what we have in front of us at the moment is a live stream of net flow data. So this is uh, a measurement of from the network of the number of internet connections that are being established. And as a service provider, we'd like to go from this big data, if you like, to a live update on the investment required to support the internet services as I described. So we have a web interface that the ISP can log into to get these live updates on their finances. And the purpose of this video is to lift the lid on what happens behind the scenes with the AI and to really explain how these live updates are made available to the ISP. Now, I've got a bit of a slow internet connection where I'm working, but yeah, the page should load very quickly. Yes, there we go. So the purpose of this video is to explain how we get this live update on the bandwidth utilization and bandwidth availability on the network. So without further ado, I will run the WAN-AI technology. Now, WAN-AI integrates directly into the network via the NetFlow live stream. And the purpose here is to determine what is the least amount of investment required when supporting popular internet services. Now, as I mentioned at the beginning, we have a unique combination of an AI component with a ultra-fast computational engine, and the two components are working in real time to provide live updates. Now, for the purposes of this explainer, I've decoupled WAN-AI from the live stream just so that we can discuss some of the underlying principles. Now, one of the things to say straight away is the reason why this technology is really disruptive is that it's extremely fast at calculating what happens to all the packets in the network at any given time. So our computational engine is currently 250 times faster than anything that's that's commercially available. And the reason why this is possible is because we're using concurrency. So we're using multiple cores to really speed up the process. And that's what gives us the live updates. But we also need an AI component that can reason based on the measurements coming in from the network. So this is what I'll cover just briefly. So we've got the AI engine that's reasoning in a multi-dimensional space. What this means is that each dimension represents a question that we're asking the AI. So for example, here we'd like to know how much bandwidth should we provision in the downstream and how much bandwidth should we provision in the upstream. So 2 dimensions. And that determines the investment that we require on the network. So based on the net flow information, the AI reasons that perhaps 45 megabits and 34 megabits is sufficient. And having made that assessment, it asks the computational engine to calculate, in effect, the user experience for that bandwidth provision. And what the CE comes back with, the computational engine, is that your app 0 will run at 46 megabits per second. 42 megabits per second. Now that's much faster than you need for YouTube video streaming, for example. So the AI needs to go through several iterations to determine what the optimal investment is, and at each point it calculates the user experience. Now, after just a handful of iterations, the AI determines that the optimal investment that's required in the network, or rather the optimal bandwidth provisioning for our network based on the level of activity on the network is 30 megabits per second in the downstream and 30 megabits per second in the upstream. Now, this is rather surprising, and I'll explain why in just a moment. When we look at the internet applications in the downstream, there's 4 TCP applications that are flowing in the downstream, and at 10 megabits per second, you would expect to be provisioning 40 megabits per second. So what the AI tells us here, that 30 megabits per second gives us a 10% margin, is rather surprising. But the reason for that is actually very simple. And to understand that, I will show you the how the internet protocols operate on the internet. So we're evaluating TCP cubic with a TCP. This is currently the state of the art, but it will soon be replaced by TCP BBR, which has been developed by Google. And you can see that when connections come in, they utilize a full bandwidth. For example, our first connection will only live for about 70 seconds and then free up the bandwidth for the other applications to fully consume. Now, that very fast service time for the application means that we are able to grab a chunk of data very, very quickly and free up the entire bandwidth for other users. That's a very efficient use of the bandwidth, and this is why TCP is now the standard for delivering data to consumers. So that is a very short video explainer. Live updates for the service provider, going from a live stream of net flow to cash flow for the service provider, and saving a significant amount of money, which improves the profit margin. Thank you very much.